Can you access your YouTube? Yes? Can you see my face? No, not here, on your screen. Oh, it's 9 o'clock, so is that I'm very sorry, but I got delay. Some trouble happens. I really do not know what happens. Um, just I followed the same way from last week. Maybe traffic, internet traffic is very busy or something. I really do not know, but anyhow, dear, let's restart today's lecture. And the files today we're going to use is last week one, number 4.1, and today's one, number 5.1. We're going to use these two. Then, yeah, English directed lecture this is, and do not hesitate to pronounce. This is very much connected to the today's announcement. Then, can you see the this in your computer? Yes. And exercise will be announced as attendance. Then attendance later, and how to get credit. And we are having the lecture here, room 313. So you can visit here, but only you three are forced to come down here. And my email address. Oops. And also the not today, but I would like to change schedule a bit. The previous schedule is my lecture. My lecture will be 7 times on the screen. This is a schedule since last week, but I have told to Okuya Sensei that I'm going to have 8 time lectures until June 9th, right? Then, as a second half, Okuya Sensei going to start his lecture on 16th, not July, June, until July 28th. That means I'm going to have 8 times. Okuya Sensei is going to have 7 times, right? And this year as well, the January lecture will be scheduled for 16 times, including examination, 16 times. But last weekend, this last year and this year, the schedule is a bit shortened because of what? Generally, the schedule, your lecture schedule will be 16 times, but this year and last year a bit shortened. Why? At first semester, we have 2 semesters. First semester from April to September, and second semester will be from October to March. At first semester, it bit shortened this year and last year. Why? We should finish our lecture until the end of July. Why? Yeah, you're right. Olympic game. So the country, Japanese government told us that you should stop your lecture until the end of July. that our schedule is, in fact, the Olympic game in last year, but it canceled. So this year as well, the first semester schedule is a bit shortened. Then today's how to pronunciation, some scientific word in English. First, announcement, important announcement. I hope the next week and week after there's no trouble on the internet. It sounds like that is not my fault. You have to prepare your introduction of yours, like a couple of minutes talking, and from for next week and week after, we're going to have your not YouTube connection, but we're going to Teams, right? But you do not necessarily to install Teams. Just you need to browse software such as maybe yours is Safari, maybe yours is Safari too, Safari, and maybe yours is Edge or Internet Explorer. What is your browser software? What is your browser software? Edge? Mm-hmm. In the case of Windows 10, generate Edge. Edge. My case is both, like Safari or Google Chrome, or maybe the guy Takeru uses a different one. Do you know the name he used? Not Firefox, not Chrome, not Safari, not Explorer, not Edge, but others he uses. Anyhow, dear. All right. From next week, we're going to have your presentation, not my presentation. And first presenter is some three of you, right? And then if you finish, you three finished, and then I'm going to ask the other person, okay? So you'll be a kind of good examples. So your presentation includes identify yourselves. That means your name, not only surname, but also you can tell us your full name and who is your supervisor or which laboratory you are belonging to, and then show us your research project, and which consists of a tentative title. You need some tentative title. We do not talk of your tentative title yet, so we should prepare. You need also some tentative title. Maybe your case is like almost same as your bachelor graduation title, and you too. So just translate that into English. Tentative title, brief abstract, then a practical application of your project or practical applications, which makes which if show us here practical application, the people listening to your presentation, it's very easy. Our area, scientific area, is now very details. So maybe some research project in your next door we do not understand. So we really need some practical application. You cannot read paper. Maybe first you write down some paper, but generally when you have presentation, you cannot read. Right? You can presentation just here, but the preparation required. So everybody needs some camera-ready devices, such as some PC or iPhone, smartphone, or tablet, whatever, camera ready. But you do not necessarily. We are here, so maybe next week I'm going to prepare some camera here, and then just three of you, just you three, going to have a presentation first, and no jargons. No specific acronyms. If you're going to use acronyms, just explain what it is. Maybe, yeah, I told that NMR, it's all right. CMT is all right, and DSSC is all right. But much more complicated acronym, if you're going to use, you have to explain. All right? Preparation. Introduce yourself. Next week we start, and next week we just connect not via YouTube but Teams we're going to use. Yep, today agenda today is some brush up, inspection of exercise, and the mini examination, and then something accent and pronunciation of scientific area. Right, brush up, inspection of exercise, maybe surely the exercises convert 80 degrees centigrade into Fahrenheit, degrees Fahrenheit. It sounds like German, Fahrenheit. I do not original the Fahrenheit, but just you can follow this equation. Conversion of Celsius to Fahrenheit is like this, and you calculate this, and answer is, my calculation is just 176 degrees Fahrenheit. Your answer is the same as mine? You don't remember? The same as mine? Yeah. So the answer is 176 degrees Fahrenheit. And I told you that I know only one country still they adopting their Fahrenheit, only United States. Do you know other countries? Maybe I asked last week as well. But, maybe Mexico. I'm not sure. In Mexico, I'm not sure. Only country, so like 90 degrees centigrade. It's really hot. It's close to 30 degrees centigrade. Brush up. Next, we have done the inspection of a mini exam. Now we're going to inspection of last week mini examination. Choose the appropriate pronunciations for this one. I need as unit. This may be required as unit. In science area, we use the reciprocal centimeter or wave number. These two are answers. Now, wave number is just combined, and you can write down like this way. And this way is correct as well. What about your answer? You get this? No? Reciprocal centimeter or wave number is correct pronunciation for this as unit. You are about to purchase 5 apples. The piece rate of it is of 100 yen. Which calculation is the most feasible way to acquire some? Yeah, addition works 100 plus, but it says that the most feasible way, so multiplication is answer. I'm sure you got this. Multiplication. 3. Select an integer. Yesterday I asked you It should be integer. Integer is only this one. What is this one? What is the name of this one? Like, what is this? What is this? This. These are, you may call this some decimal fraction. Decimal fraction. This point is decimal point. Decimal. And what is this? Other is whatever. What do you call this group? Last week we did fraction. This is fraction. Remember? Right? Fraction. These are fraction. And these are decimal fraction or just decimal. Decimal fraction integer. This is a decimal. Decimal fraction. This logarithm. What is the base of ln? What is the base of ln? Last week I asked you ln equals log e. You may call this base. (23) is integer. For factorize the following equation and choose the answer. X squared plus 5x equals 24. You understand now what is factorize? And I think is this answer? This one of those is answer. Which one? 8 times 8, 64 minus 40 is 24. Yeah, 24 and 3. 3 times 3 equals 9, 15, 24. Yeah, I guess this is answer. Am I correct? Oops. The answer is x equals minus 8 and 3. That is answer. Question 5. Make an appropriate choice describing the area of a right triangle. Right triangle. Can you write down here? Can you draw the right triangle here? Can you draw here the right triangle here? Right triangle. Here, just a tiny space, but here, yeah. Go ahead. Right triangle. What is this? This is not a triangle. Right triangle. Do you know what is right triangle? Maybe you want to write this way, right? Like this, right? Right triangle is, this is right triangle. How much angle is this? 19. What is unit? 19. What is unit here? 19. Not 19. 90. 90. What is unit? 90 degrees. 90 degrees. This is right triangle. This one is triangle. The question is, make an appropriate choice describing the area. Area or like other group is like a volume. What is some typical unit of area? Square centimeter. Similar question. What is your typical, atypical volume unit? This is square centimeter. This is cubic centimeter. Cubic centimeter. And I guess the area of the right triangle and general triangle is same. It's same calculation equation. So the answer is, it is the right angle area equals half of the base times height. This is base. You may call this as base. Base times height divided into 2. It's a triangle area. And this one is base as well. You answered. This is base. And this is base too. A bit complicated, but yeah, they're sharing same verb for those. Okay, today's exercise, I'm going to ask you just one exercise, and you send me this answer via chat function. Your answer should be student ID space your answer. The question is, exemplify some allotopes, not isotopes, allotopes. Show me the example of isotopes, some isotopes. Isotope example, or maybe examples, isotope examples. Isotope examples. Yeah, we use the word isotope often. Isotope examples. Isotopes are, example, proton, deuterium, tritium. These are isotopes, isotopes group. And 19 fluorine and 18 fluorine is like isotope groups. You got it? So show me some radioactive isotope. Radioactive isotope. Radioactive isotope. Radioactive isotope. Example, in the case of hydrogen, proton is not radioactive. Deuterium is not radioactive because these are, we often use this to, like in our cases, water. H2O we use a lot, or in our cases, for animal solvent, we use D2O. They're not radioisotope, but tritium is radioisotope. Yeah, you hear often tritium these days. What is tritium? Which kind of news genre? Tritium is treated. Tritium. Tritium. Their symbol, element symbol is proton, this one, right? And this is 1, 1, 2, 1. This is deuterium, right? Or D, T is 3, 1, H, tritium. Tritium is like a power factory west in Fukushima. which contains tritium. Do you know half-life of tritium? Half-life of tritium. Yeah, you should know that. You're a scientist. You will be a scientist. Approximately 12.3 years, I guess. 12.3 years, which emit beta ray, which tritium emit beta ray, and then finally, which makes helium something. I don't remember well, but anyhow, helium something. Tritium is radioisotope element. But the question is, show me the allotopes. Can you give me some allotope example? Yeah, you can show that example, and you may send me that answer. Some O2 and O3. Yeah, that's allotopes. Very good, very good. Oxygen and ozone is allotopes. Other example? Yeah, maybe in your laboratory we're talking of the Raman spectroscopy in the literature, a paper reading on Thursday. Raman and two peaks of some carbon materials. One is from sp3, one is from sp2, and those time we are talking of some allotopes. Allotopes? Graphite and diamond is allotopes. Very good. So show me the send me allotopes. And maybe we have to touch the some leftover from the last week. So we are going to which one? Oops, I don't see that here. Yeah, we are talking of some mathematics things, round off. Yeah, yesterday I told you, round off. 1.5753 is rounded off to 1.85822 decimal places. This is round off. But maybe O-sensity is something like this. O-sensity. O-sensity is something like this. So we cannot use the just balance record because which has O-sensity. Proportion. This is quite important. And this is figure, I have already showed it. And proportion is like the current increases in proportion to voltage. Did you get proportion? Like this, proportion is. Or this is proportion to 0 point doesn't matter. A proportion is something like this. These are proportion. The current increases in proportion to voltage. The expression is something like that. When you have some presentation, the current increases in proportion to voltage. This is quite a general expression of the proportion. Or the current decreases in proportion to voltage. It's like this. This is decrease like this. These lines are y-axis shows the current, and x-axis shows the voltage. So the current decreases in proportion to voltage. The current is reduced in proportion to voltage. It's same, exact same other expression like that. The current increases commensurately. It's same, it's proportion, it's same as proportion. Different, just different expression like this. The current increases commensurately, it's same, proportion, in proportion. Just you can remember, in proportion. The current increases in inverse proportion. It's same as the current decreases in proportion to voltage. Completely equals the current decreases in proportion to voltage. So, and show some lines like this, like that, like this. These are all the current increases in inverse proportion. Inverse proportion. The current increases as voltage increases. Oh, this is very hard to write. So the current increases as voltage increases. So everything is something like that. This or these curves as well. These and these also. The current increases as the voltage increases. The current increases in an exponential fashion. Which is exponential curve? This is exponential. This or this or this. Which one is exponential? Exponential curve. This one. This is. He says. This is exponential. I'm not sure. Exponential equal. Yeah, you're right. This green one, these are exponential. This is exponential, right? And this is just like red line is just a proportion, and the blue line is like exponential. These are something basic things not related to mathematics, but these big letters A, B, C, D, you may call these groups as capital, or capital letter. Yeah, yesterday you showed me some animals. You named some proton as H small a, H large A. Those large A, you may call those capital or capital letters. What is capital? Others, in meaning others, capital. What is capital? You understand. I know you understand, but what I can explain. What is capital? in Japan, in Tokyo is capital. So what is capital? Diet is there. Diet means in Canada you may call that diet. In Japan as well, Congress, the place which meeting of national meeting like congressman gathers. Those places, those city, you may call that capital. Maybe the explanation is not so good. All right, so the capital, other capital is capital letter. This big ABC is capital letter. Tiny one is small letter or lowercase letter. Just small letter is general. Capital is just general. Capital, small. Word, phrase, sentence, paragraph. You can explain this. Word. Word is just word. Phrases, sentences, paragraphs. We have learned that homophone and antonym, whatever, but they do not have specific word, but quite crucial in a scientific area. I have already shown the pseudo. You don't pronounce the top P in this one as well. Can you pronounce this? The second word. First one is pseudo, like a pseudo first order reaction. Pseudo order reaction. Those are pseudo. And what is the pronunciation of the second one? Second, psychological. Excellent. Psychological. You do not pronounce this. Psychological. Like in your mind, something you're thinking. Psychological. I get very shocked psychologically. So there's no injuries, there's no wound outside, not bleed, but in your mind you get some shock psychologically. It's like psychological. You don't pronounce this. Pseudo, psychological. These are crucial words in science. This is the other side. You do not pronounce at the end of the word lamb. What is lamb? What is lamb? You're yawning. Yawn. You're yawning. What is lamb? What is lamb? I think sheep meat is lamb, isn't that? Sheep meat is lamb. Or lamb or mutton. Adult sheep meat is mutton. Child sheep meat is lamb. Not goat meat, right? Goat and sheep different, right? We don't eat a goat a lot in Japan, right? We eat, for example, if you visit Hokkaido, there's some restaurant of the Genghis Khan. Genghis Khan is lamb. What is crime? Of course, you don't pronounce this B. What is crime? Explain me crime. Crime. Yeah. You're correct. Climb a mountain means you just walk and elevate the height and walk. It's climb. Bomb. Dynamite is kind of the bomb, right? Comb. This you have noun and verb. Comb. Oh, In fact, we derated so dear. That's my fault. In fact, it is not my fault, but I just operate properly, but internet looks so busy, so I cannot connect via internet. Anyhow, comb. Comb is like he's combing his hair with his hand or something, combing, or like just a plastic or something that you may call that comb. Comb. You don't pronounce B. Thumb. 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 What is thumb? When you tease a person, your all finger looks thumb. Your fingers all thumb. Thumb. Very good. Thumb. So teasing is your finger or thumb means someone could not trade nicely. Like trading is not so good. Experiment is like not good. Your finger is all thumb. Oh, like very much sometimes slippery things or Butterfinger or something. And you have the thumb. You don't pronounce the end. Oh, you don't pronounce the middle word. Edge. Edge means like edge. Ledge means it's difficult to explain, like something. There's a rock, and the shape is like hierarchical something. This is ledge. Batch means you have a very good batch. You get those batch celebrating his birthday or something like batch. Lodge means like Udi Lodge. Last night I stayed in Udi Lodge. Last batch. What is batch? This batch is badge. This batch. Badge. I don't find a good example. Anyhow, dear, you don't pronounce the middle of the word batch. Okay. This is not. No. Now we're going to do some elements, atoms, and others, scientific area, English expression, and I belongs to Shizuoka University, but I have also a course in university in Thailand, and I am teaching in Thailand University as well. And the title of the lecture is not Advanced Energy Chemistry, but Supramolecular Chemistry. It's very not familiar with you, I guess, this supramolecular chemistry. You never heard before. Supramolecular chemistry. You do not know. Have you ever heard the word supramolecular chemistry? No? Yeah, I can explain. Don't worry. This is a mice. So this mice is some material, biological object, or maybe organisms. Organisms. It's like mouse or a human being. Is and insects, whatever. Yeah, anything. Those are some living system, and we just divide those things into pieces. Now on, we're going to divide our body into pieces, right? And this one is, what is this? You know what is this? Can you guess this? I think this is I think this is hemoglobin. Hemoglobin. Hemoglobin is like a source of the blood red color, iron complex. Hemoglobin. That means this is protein. You're going to divide your body into pieces. Maybe one of the ingredients of proteins like hair proteins, skin proteins, uh, anywhere we have proteins. You have a lens inside your eyes, which name is alpha crystalline. Those are protein as well. We have many nails. These are proteins. Proteins. Now divide it into more pieces. Protein, some living system, organisms, protein, and then you divide protein into much more tiny part is like molecule. Molecules, molecules. And then we just continue, divide molecule into more pieces. What happens? Right? Human being, protein, molecule. What is next? Watch this picture. Yeah, atoms. Very good. Atoms. But we do not stop yet. Then we divide atoms into more pieces. What happens? Yeah, like maybe next to atoms or like what is atom consist? What atoms consist of? What? You divide atoms into more pieces. A good example is proton, deuterium, tritium. What? Example, electron. Others, proton. And H2O, H do have proton but do not have something. I'm asking you something. You understand the Japanese word, but you cannot get English words. You may call this neutron. How many neutrons does deuterium has? How many neutrons does deuterium have? Same question. How many neutrons does neutron have? Just one. I'll write down here. 1, 1, and 2, 1. This is mass number, right? So 3, 1. Tritium has 2 neutrons and radioisotope. And we don't stop yet. We divide proton and neutrons divided into pieces. What do you get? more. I guess electron you cannot anymore. That means the group of electrons, you're going to divide proton or neutron, divide into more pieces. Those pieces are closely related to Hamamatsu. Oops, or maybe different, different picture. Yeah, here. We're going to divide neutron, proton into pieces. It's like you may call those pieces are like quantum particle. Quantum particle or quantum particles. Yeah, you see these pictures. Nucleus. So inside of the nucleus, you have neutron and protons, and you these are proton, electron, and others, and quantum particles. Like these are example of the quantum particles, like up, down, charm, strange, top, bottom, or blah 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 blah. Which quantum particle is closely related to Hamamatsu? Detection. Yeah, this one. You know what is this? This is a photo multiplier tube by Hamamatsu Photonics. Kazukio gets job in Hamamatsu Photonics. In huge diameter is something. This one is small, 80 centimeter or something like that. This one you can see this in a campus museum, Takayanagi Museum. And photo multiplier tube by Hamamatsu Photonics is placed in old mine, which calls Kamioka mine, which has huge holes, a big hole, and now you use that is mine. Do you know what this mine is? Mine. Example is gold mine. Gold mine is in Japan many years ago. We have gold mine in Sado Island. Gold mine or silver mine. I think Kamio mine is copper, bronze mine. Mine is something like that. Mine. Now you have Kamio Kande. There is 1,050 photomultiplier tubes and 3,000 ton pure water inside. And they're going to detect what? One of the quantum particle. And the present one is, this is Kamiokande. This is super Kamiokande. Present is, it's on already, 11,200 PMT. PMT is photomultiplier tubes and 50,000 pure water. And then now, and the construction is like almost 100,000 PMT and 1 million ton pure water inside, and detecting one of the quantum particle. Right, so they are not only exercise, but if you know the name of the quantum particle which is detected in Kamiokande or super Kamiokande. And the construction one is hyper Kamiokande. Send me the name of the quantum particle, right? Okay. We got not we, but two Japanese get the Nobel Prize in 2002 and 2015. In 2002, Professor Koshiba get the Nobel Prize, but he passed away for a couple of months ago, I think. And Professor Kajita get the second Nobel Prize by the Kamiokande in 2015. I don't know the answer. Name of the quantum which one? Yeah, this one. Neutrino is detected by Kamiokande and super Kamiokande, and those detections gave two guys Nobel Prize of physics. But the apparatus is from Hamamatsu techniques. This is a device which converts light into electron. Light to electron convert device. Yeah, there are many devices. Camera is the same. Convert light into electric current. CCD camera, maybe you have in your computer, you have camera. Those devices are same. Neutrino. They detect neutrino, and neutrino has some weight. They discovered that neutrino has the weight. Okay, now talking. Lecture is going to nucleus at the center of the atom, or something proton, neutron, an atom, but time is almost close to the end. What is next? Oh, maybe we just going to do that. Some quantum numbers. Do you remember quantum numbers? Quantum particle is just tiny pieces. It's tiny, smaller than neutron and proton. But quantum number is numbers which defines the atoms, quantum numbers. We have 4 quantum numbers. First quantum numbers, the symbol is n. As mature quantum numbers, the symbol is L. Magnetic quantum numbers, the symbol is M. And spin quantum numbers, the symbol is I. We have 4 quantum numbers. You have already learned it, quantum numbers. Do you remember what is the quantum number of proton? Excuse me. What is the spin quantum numbers of proton? I equals a half. This is spin quantum numbers. Proton is a half, 1 second. And there's some quantum numbers, for example, B11. You may pronounce this as B11 or B10. In the laboratory, we use here B11 number. Yours B10, B11. Do you remember the B11 I number? Maybe 3 seconds or something like that. I don't remember. I don't remember well. It's very quite affects the NMR detection. So there we have 4 quantum numbers, right? Oh, what is next? Shells, K shell, L shell, M shell, N shell. You learned it already in high school, junior high school. But the Japanese word, we know that. English word is shell, shells. Then K shell, L shell, M shell, N shell. And the first quantum number is 1, 2, 3, 4. Oops. 1, 2, 3, 4, and 2 times n squared is just 2, 8, 18, 32. And what is these numbers? K shell, L shell, M shell, N shell. What is these numbers? I'm asking. This is first quantum numbers. Yeah, you understand, but you cannot find out the good English words. Is a number of electrons. Number of electrons. Number of electrons. Right? We are close to the 10 past 10 souls. I gradually finished today's lecture, and next week I told the presentation of yours via Teams. You do not necessarily to install the Teams. Just you need to browse the software, and I'm going to try to call you around 8:30 or something like that. And first 3 buttons are use 3, right? Okay. That's all. We finished today. See you next week.